you.
Welcome to another episode of the Part 145 EASA training from Phoenix Way Academy.
Hi, I'm Sarah.
Hi, and I'm Sam. Well, in this deep dive, we're going to continue our exploration of EASA Part 145 regulations. We're specifically focusing today on Clause 145.A.65, Maintenance Procedures. This is really a foundational section for aviation safety.
Absolutely. You could say 145.A.65 is where the rubber meets the road. It really lays out how maintenance organizations must ensure safety, quality, and, well, rigorous compliance in every single task they perform.
It really is about building trust, isn't it?
Exactly, from the smallest repair right up to the largest overhaul.
Okay, so our mission today is to really unpack these procedures. We want to move beyond just, what the regulation states and try to understand the underlying principles, maybe some of the subtle challenges, and how they translate into the demanding realities of aviation maintenance.
Right. We'll look at the core requirements and then dig into the practical guidance. That's the acceptable means of compliance, the AMCs, and the guidance material, the GMs. They really help make these critical rules, well, actionable.
Okay, let's jump right in then. We'll start with the core requirement itself. Clause 145.A.65, subclause A. I'll read what the regulation states. The organization shall establish procedures which ensure that human factors and good maintenance practices are taken into account during maintenance, including subcontracted activities, and which comply with the applicable requirements of this Annex, Annex I, Part M, and Annex VB, Part ML. Such procedures shall be agreed with the competent authority.
What really stands out there for me is the immediate and explicit emphasis on human factors. Right at the beginning.
Yeah, it's not just tacked on at the end.
Exactly. It's not an afterthought. This clause basically acknowledges that even the most technically perfect procedure can fail if that human element isn't carefully considered. It's a proactive stance against common maintenance errors, really.
That makes sense.
And if you connect this to the broader landscape of aviation safety, it's a recognition that airworthiness isn't solely about the mechanics of a machine. It's profoundly influenced by the people doing the work, their state, their environment, how they interact with the process itself.
Right.
And that last part, the requirement for agreement with the competent authority, like EASA, well, that underscores a crucial point. These aren't just internal company guidelines. They're legally binding blueprints for safe operation.
That's a really powerful distinction. So it means that when a maintenance organization develops, say, a brand new procedure for a complex engine component repair, they can't just list the technical steps.
No, absolutely not.
They must actively think about things like, well, how noise in the hangar might affect communication between mechanics, or how shift patterns could lead to fatigue. Maybe even the design of the tools themselves to minimize human error. That's the human factors part in action.
Precisely. And those technical steps themselves, they have to reflect the absolute best, safest industry practices.
Yeah. I imagine a common pitfall is focusing too much on the what of the task and less on the who doing it or how the environment impacts them.
That's exactly right. This clause forces that holistic view. And importantly, if a specialized team is brought in, maybe for a critical welding repair, their subcontracted work also has to adhere to these same high standards.
Okay.
And the entire procedure document needs that stamp of approval from the aviation authority before it can even be used. It's a really comprehensive safety net.
So just to summarize that first point, 145.A.65 essentially mandates that maintenance procedures must integrate human safety, industry best practices, and compliance with all the relevant EASA parts, Part M and Part ML included, all subject to mandatory approval.
That's it. That holistic approach ensures every aspect of maintenance is contributing to airworthiness.
Okay, so building on that foundation, let's explore what these maintenance procedures specifically need to address. This is outlined in Clause 145.A.65, subclause B. It starts, the maintenance procedures established under this point shall, and first, subclause B1. 1. Ensure that a clear maintenance work order or contract has been agreed between the organization and the person or organization that requests the maintenance to clearly establish the maintenance to be carried out so that the aircraft and components may be released to service in accordance with point 145.A50.
This brings up an important question, doesn't it? Why is such a detailed work order or contract so critical that it's, explicitly called out in the regulation like this?
Yeah, seems quite specific.
Well, it's the very cornerstone of trust and accountability. It defines the precise scope of work. That prevents costly misunderstandings or, worse, disputes between the maintenance organization and the client. You could almost think of it as the ultimate prenup for aircraft maintenance.
Ah, I like that analogy.
Without that clarity up front, achieving a proper release to service that's 145.A.50, it becomes a legal and operational minefield. It's not just about documenting what was done, but proving what was agreed to be done in the first place.
That's a great point about the prenup.
Uh-huh.
So let's imagine an airline brings an aircraft in for a routine check, and they also ask for a specific repair to a landing gear component.
Okay.
This subclause means there has to be a meticulously detailed work order, a clear agreement that spells out every single task, the exact type of inspection, which specific landing gear part, what exactly that repair involves, maybe any other agreed services, perhaps even a basic wash.
Right, down to the details.
Exactly. This stops the airline from later saying, oh, we thought you were also going to repaint the tail, if it wasn't explicitly in the contract. And for the maintenance organization, it's what lets them confidently sign off on the aircraft's airworthiness because they know the defined scope of work was fully and correctly executed. It really protects both sides.
It does. Clarity is key.
Okay, next up is subclause B2. Cover all the aspects of carrying out the maintenance, including the provision and control of specialized services, and lay down the standards according to which the organization intends to work.
What's truly comprehensive here is that phrase, cover all aspects.
Hmm.
This means the procedures aren't just for the wrench turning itself. They have to encompass everything from the moment the aircraft arrives to tool control, quality checks, documentation, all the way through to handing the keys back, so to speak.
A whole life cycle of the maintenance visit.
Precisely.
Yeah.
And the specific mention of specialized services is really important. It points to areas needing unique expertise or maybe special equipment, things like certain complex welding techniques or advanced testing methods.
Right.
It basically underscores that a Part 145 organization isn't just a collection of skilled technicians, it's a highly systematized operation. Every step, every single action is governed by clear processes and established quality standards. This ensures repeatability and safety, no matter how niche or specialized the task might be.
Okay, so let's take an example. Say an aircraft needs an extensive structural repair involving composite materials. That's definitely a specialized area.
Absolutely.
This clause means the maintenance procedures must cover everything. How the damage is assessed initially, the precise materials and tools to be used, the exact curing process for the composites, even critical environmental conditions in the workshop, like temperature and humidity, which are vital for a proper cure.
All those variables need controlling.
Exactly. And if they decide to subcontract a specialized non-destructive testing service, NDT, to check the final repair, the procedures must detail how that NDT service is managed and controlled, defining the high standards required for all these complex tasks. It's about making sure the final repair is absolutely airworthy.
Leaving nothing to chance.
Right. So, to summarize Clause 145.A.65b, it ensures maintenance procedures are both crystal clear in the contracts with clients and also exhaustive in covering every single maintenance activity, including those specialized ones, always sticking to defined quality standards.
That dual-focused contractual clarity and procedural thoroughness is indispensable for robust and safe operations.
Okay, that brings us nicely to how these procedures aren't just, written once and then stuck on a shelf. Let's dive into the guidance on maintaining them. This is an acceptable means of compliance 1, or AMC 1, for Clause 145.A.65 under the General section.
Right, and the guidance here states, maintenance procedures should be kept up to date such that they reflect the current best practices within the organization while being compliant with the regulation. All organizations' employees should report differences via their organization's internal safety reporting scheme. All procedures and changes to those procedures should be verified and validated before use where practicable and applicable. All procedures should be designed and presented in accordance with good human factors principles.
This AMC really highlights that procedures are living documents, aren't they? Not static ones.
Absolutely. That emphasis on being up to date and reflecting best practices is really a call for continuous improvement. It's about being responsive to new technologies, lessons learned from incidents, or even just finding better ways of working.
And what I find really progressive here is the explicit requirement for employees to report discrepancies through an internal safety reporting scheme.
Yes, that's crucial. It fosters a truly proactive safety culture. It empowers the very people on the hangar floor, the ones actually using the procedures, to identify issues and contribute to improving them. It goes beyond just ticking a compliance box. It's about building an active feedback loop.
That makes a lot of sense. And the verification and validation step.
Also critical. You don't just implement a new or changed procedure straight away. You need to test it, verify, and validate it to make sure it actually works as intended. And importantly, doesn't introduce any new risks before it goes live on operational aircraft.
Okay, so let's take an example. Imagine a maintenance organization introduces a new, maybe highly advanced diagnostic software tool for troubleshooting complex aircraft systems. Right.
According to this AMC, their existing troubleshooting procedures must be updated immediately to incorporate this new tool, reflecting the most efficient and accurate ways to use it.
Okay.
Now, if a mechanic, while using that updated procedure, finds a step that's maybe unclear or ambiguous, or perhaps could even lead to an error if they misinterpret it.
Which can happen.
Exactly. They are expected to report that through the company's internal safety reporting system. And before this updated procedure becomes the standard for live aircraft maintenance, it should be rigorously tested, validated maybe on a non-operational aircraft or even a simulator to ensure it's truly effective and safe.
And this whole process, again, is designed with human factors in mind, ensuring it's easy to understand and use, ultimately preventing errors down the line. So this AMC is a strong reminder, then, of the dynamic nature of these procedures. They need constant updates for best practices in compliance. It also stresses the vital role of employee feedback via safety reporting, and that critical step of verifying and validating changes, all while sticking to human factors principles for usability and safety.
Absolutely. You know, we keep mentioning human factors principles, but what does that really mean in practice day to day? Let's maybe zoom in on that, because Guidance Material 1, or GM1, for Clause 145.A.65 gives some incredibly specific and valuable insights into how procedures should actually be designed and presented.
Okay, yeah, let's unpack that. This GM provides a tangible, almost like an actionable checklist for developing procedures. It goes beyond just a theoretical consider human factors.
Right. It says, for instance, under point A, that the best procedures aren't written in some ivory tower by theoretical experts. They are co-created with the very personnel who will actually use them on the floor. That's a practical, real-world insight right there.
That makes perfect sense. Get the end users involved.
Exactly. It also stresses critical thinking about the who and where, tailoring the procedure to the user's level of expertise, that's point C, and the operational environment where it'll be used, point D. And the emphasis on clarity, simplicity, consistency across all aspects of the design, especially language, points E, H, and I, that's crucial for minimizing ambiguity and potential errors.
And I found point F really interesting, where appropriate, explaining the reasons for the procedure.
Yes. How often do you see procedures where the why is just missing? That's such a common oversight, and it can lead to technicians taking shortcuts or making mistakes if they don't really grasp the underlying safety reason or the operational criticality of a particular step. Explaining the why really helps foster proper compliance.
Absolutely. Okay, let's try and unpack this with a practical scenario, say replacing a specific sensor on an aircraft wing following this GM.
Good example.
So under A, the procedure shouldn't just be written by someone in an office who's never done it. It must involve experienced mechanics who actually perform this task.
Right.
That ensures it's practical and effective right there on the hangar floor.
Good sense.
For B, it needs to be perfectly accurate, easy to follow, and reflect the safest, most efficient current industry best practices for that specific sensor replacement.
Okay.
Under C, if the procedure is maybe aimed at entry-level technicians, it needs more explicit detail, probably more diagrams, and simpler language than one written for highly experienced engineers who already know the context.
Right. Tailor it to the audience.
And D, you have to consider if it's mostly used outside in the rain, or maybe at night under poor lighting, or inside a really noisy hangar. Can the technicians actually read it clearly? Is the format robust enough for that environment? The environment really dictates the design sometimes.
That's a very practical point.
Point E ensures all the crucial steps for replacing the sensor are there, but without unnecessary jargon or redundant information or extra steps that just make it overly complicated or take too much time. Keep it lean but complete. Under F, it might explain why a specific torque setting for the sensor mounting bolts is absolutely critical for safety and why deviating could lead to failure. That context is invaluable.
Understanding the why.
For Chias, if the bolts must be tightened in a specific sequence for structural integrity, the procedure has to state explicitly that this order is critical. If the order doesn't actually matter, it should say you can vary it. Clarity on criticality.
Right. No ambiguity.
And it's all about consistency. Every diagram, every abbreviation used, every instruction needs to be consistent with other procedures they might encounter within that same organization. So there's no confusion or constant relearning of terms.
Standardization is key.
Finally, for EWE, especially for documents produced in English, they must use clear, simple language. Avoid overly complex sentences or obscure technical terms that could easily be misinterpreted, perhaps by a technician whose first language isn't English. It's about reducing cognitive load.
Wow. That detailed breakdown really shows the depth of this guidance, doesn't it? So, in summary, GM1 gives us this comprehensive framework for designing truly human-centric procedures. It's about involving the users in the design, ensuring accuracy and usability, tailoring it to the user's expertise and the specific operational environment.
Prioritizing clarity, explaining the why, defining critical steps clearly.
Maintaining consistency using simplified English, all ultimately designed to make procedures effective, reduce ambiguity, and minimize the chance of human error. It's a very practical guide.
Okay, now let's circle back quickly to those maintenance contracts we discussed earlier.
Yeah.
Because Guidance Material 2, or GM2, for Clause 145.A.65 subclause B1, gives us even more specific insight.
Yes, the contractual side. The guidance here states, Appendix XI to AMC MA708C, or Appendix 4 to AMC 1 CMO.315C, provide guidance on the elements that need to be considered for the maintenance contract between the CAMO and the maintenance organization. The Part 145 organization should take into account these elements to ensure that a clear contract or work order has been concluded before providing maintenance services.
What's really valuable here is that this GM doesn't just vaguely suggest good practice. It points us directly to specific EASA appendices. Appendix 11 to AMC M.A.708 subclause C, or Appendix 4 to AMC 1 Camo.8.3215 subclause C.
Right. It gives you concrete regulatory reference points for how to structure these critical maintenance contracts. These are the agreements between a continuing airworthiness management organization, the CARMO, and the Part 145 maintenance organization. It essentially elevates that contractual clarity from just being good business practice to being a fundamental regulatory requirement.
Okay, so if a Part 145 organization is about to perform, say, a major C-check for an aircraft that's managed by a CAMO,
A common scenario.
this KM means they don't just draft a simple generic agreement. They would actually consult Appendix 11 or Appendix 4 to make sure their contract includes all the necessary elements. Things like precise details on the scope of work, conditions for access to the aircraft and its records, clear financial terms, defined responsibilities for any unserviceable parts found, logistics for component transfer, and so on.
It covers all the bases.
Exactly. This ensures there's no ambiguity later on. It creates a robust legal and operational framework, laying the groundwork for a smooth and compliant maintenance event before the first wrench is even turned. Without these detailed guidelines, you could easily get into arguments about scope creep or other legal headaches.
Yeah, it prevents problems down the road. So GM2 for 145.A.65B1 essentially directs Part 145 organizations to these specific EASA appendices. This ensures comprehensive and clear maintenance contracts or work orders are established with CAMOs before starting any services, meticulously defining responsibilities and the scope of work right from the outset.
Okay, great. Finally, let's wrap up by looking at acceptable means of Compliance 1, or AMC 1, for Clause 145.A.65, subclause B2. This one elaborates further on the control of those specialized services we talked about.
Right, the specialized stuff. The guidance states, specialized services include any specialized activity, such as, but not limited to, non-destructive testing requiring particular skills and stowaway qualification. Point 145.A30 covers the qualification of personnel, but in addition, there is a need to establish maintenance procedures that cover the control of any specialized process.
So this raises an important point again. Why do we need separate, distinct procedures for these specialized processes, even if the people doing them are already highly qualified?
That's the key question. This AMC highlights the crucial distinction between personnel qualification, which, as it says, is covered comprehensively by Clause 145.A.30 subclause F, and the rigorous control of the process itself.
Okay, so it's not just the person, it's the whole process.
Exactly. Specialized services like NDT, non-destructive testing, involve not just skilled individuals, but often unique, highly sensitive equipment. They might need specific environmental controls like temperature or humidity constraints, and they rely on precise, repeatable methodologies that absolutely must be followed to the letter. Even with the best human experts operating the equipment, the process has to be meticulously defined, documented, and controlled to ensure you get consistent, reliable, and safe outcomes every time for these high-risk niche activities.
It's about standardizing the excellence, minimizing any variability, even when you have top human skill involved.
Precisely. Standardizing excellence is a good way to put it.
That's a powerful nuance.
Yeah.
So take an aircraft that needs a crack inspection using eddy current testing. That's a highly specialized NDT method.
Yep, very common.
Clause 145.A.30F ensures the NDT technician doing the test is certified and skilled. But this AMC 145.A.65B2, means the organization must also have a detailed procedure specifically for the eddy current inspection itself.
Okay, so what would that cover?
Well, this procedure would meticulously cover things like how the equipment must be calibrated before every use, the exact scanning pattern required on the aircraft structure, the specific acceptance criteria for any indications found during the test, the precise environmental conditions required for the test to even be valid, and exactly how the results are formally recorded and signed off.
Wow, okay, very detailed.
Right. This comprehensive procedural control ensures that even with a top-notch qualified technician, the process is consistent, reliable, and produces accurate results every single time. It fundamentally contributes to the overall airworthiness and protects against even minor deviations that could potentially have major safety consequences down the line.
That makes perfect sense. So this AMC clarifies that beyond just ensuring individual personnel are qualified, maintenance organizations absolutely must establish specific and rigorous procedures to control all those specialized processes, like NDT. This ensures these complex, high-skill activities are performed consistently and to the highest standards, guaranteeing both safety and quality in the final outcome, regardless of which qualified person is actually performing the task that day.
And that wraps up our deep dive into Clause 145.A.65, maintenance procedures. Wow, we've really seen how truly critical these procedures are, covering everything from meticulously considering human factors and establishing crystal clear contracts, right through to ensuring dynamic processes and rigorously controlling specialized services. It really is the backbone of safe and effective aviation maintenance.
Indeed it is. It just reinforces that every single detail, every procedure, every agreement, no matter how small it seems, contributes to the overarching safety and airworthiness of aircraft. Understanding these regulations like 145.A.65 is absolutely key to establishing and, crucially, maintaining those high standards across the industry. And it's not a static target, it's a constant evolution.
That's a great point. Okay, in our next deep dive, we will move on to Clause 145.A.70. That's the Maintenance Organization Exposition, or MOE. We'll explore this crucial document that defines how an organization complies with all the Part 145 requirements and essentially serves as their primary operational guide.
Sounds good. And before we sign off, just a reminder to follow us on social media. You can find us under the name Phoenix Way Academy.
Thanks so much for listening. Stay safe and stay informed.